Okay, I'm just about to start here. So for those who don't know me, I'm Denis Morais. I'm the Chief Technology Officer here at SSI, and I'll be the one conducting a majority of this presentation and demo on the SSI Enterprise platform. So the first slide we have to give is our safe harbor statement. So a lot of the product that you'll be seeing here and some of the dates I'll be stating are forward-looking. So there's always some risk to make business decisions on what you see or hear today. So it's just our normal safe harbor statement. So the topics I'll be discussing today is because SSI Enterprise Platform is focused on integration, I'm just going to talk a little bit about some of the integration challenges which I believe we all have encountered through the various amounts of integration projects that we've been involved in. Then I'll start talking about the SSI Enterprise Platform and how that solves a lot of those problems. And then I think why the majority of you guys are here is really to look at the publisher, what we have, as well as to do a quick publisher demo, just to kind of give you some better understanding of what the publisher is, so you can understand pretty much the results of our hard work. So integration challenges. So as we have had a lot of experience working with integration, some of the challenges that we've had over the years and some of the challenges that our clients have is really trying to get expertise in integrating both systems. So usually when you're trying to integrate two systems, you really ideally want expertise in both systems so that when you implement an integration, it is actually as high efficiently as it possibly can, so you can exchange data relatively well. Also, having experience in both systems really leverage the case that you can maintain the system and the integration a little bit better than if you have an expertise in just one. However, in reality what ends up happening is because you're finding the expertise in both systems is very difficult, you end up just leveraging one person or one company that has expertise in a particular system, usually the one that's a little bit more significant to your organization, and then they do the integration. And then what ends up happening from there is that when you end up doing that integration, it's not using the best methods of integrating the two systems or connecting the two systems. And then when you have to upgrade one of the systems, the integration ends up failing. And you end up getting into the state where when you want to upgrade one of the systems, you have to also upgrade your integration. And because there's two different owners of the integration and of the system that you're upgrading, you have to be in sync of those departments to see when they have time to upgrade it at the exact same time. So we've had a lot of clients that wanted to upgrade to a newer version of ShipConstructor, for example, but were unable to because they had to wait for their IT department to have time to update their integration. So not being able to upgrade is a cost being more of an opportunity cost. Availability and accessibility is a very important difference in integration. It's subtle but very important. When you look at accessibility, and a lot of the vendors, when they do integration, they really trying to make their data a little bit more accessible. So as you already know, ShipConstructor already supports an open architecture with our APIs, SQL, and many various ways of accessing information. So we don't really hold your information hostage. But what was really needed for integration is you need your information to be available. Accessibility is really just the first step. So the difference between accessibility and availability is you can kind of think of your organization now, and you have a stakeholder that requires some information from ShipConstructor. They can, in theory, go to a drawing, for example, open it up and extract some information, such as bill of materials, to use to integrate into their own system so that information is accessible for them to use. But what you really need for integration is that you want that stakeholder that's working in a different system to have all the information from ShipConstructor and the Marine Information Model to be available in the product that they're using, and to make sure that it's accurate and up to date so they can make business decisions on the information that's available. So the accessibility is really just the first step, and it's very important that integration focuses on availability. One of the challenges I've seen with integration is workflow. And the main challenge of workflow is because people don't really concentrate on workflow when they do their integration. When you do integration, most people are just really focusing on exchanging information, and therefore just really focusing on how does information have to get transferred, or what information has to get transferred. And what ends up happening with a lot of the integrations is that you end up having this, what we call a recipe type workflow, where you have either end user or certain stakeholders having to follow a recipe, just like when you're baking or cooking, in a specific order. And if they miss a step, or if they do it out of order, the results that you're going to get at the end are not ideal. And then therefore you can start making incorrect business decisions because of the incorrect data that was passed. So workflow is probably one of the main areas that's probably overlooked when you're doing integration. Being adaptive and agile, or having an adaptive and agile solution is one of the challenges. And what ends up happening is that you want to have your integration to change, or to embrace changes in essence with your organization. And the systems, the applications, the processes, your business goals, all those factors change from year to year. So your systems that you're using today is going to be different from your systems that you're using in a year from now, 2 years, or even 3 years. And you want a solution that will be able to allow you to change your business processes without inhibiting those decisions. So you don't want your integration to really inhibit your changes to your environment, to your marine environment. With integration, a lot of times your systems are accessing information from multiple applications, but also the same application. And if you have multiple applications accessing it from one single source, which usually ShipConstructor is in that case, where you're integrating with your ERP system or your PLM system or your production floor work packages, is that it's all accessing information from the marine information model. And what you want is that you want to make sure that all this information is consistent throughout all your applications in your environment. So having your integrity of your information across your ecosystem is very important. And it has been a challenge mainly because of the way that we implement our projects being more departmental focused, being one department doing their integration and another department doing their integration without really communicating. For successful integrations, you really want a good modular implementation. So you want to have a strategy that when you're implementing your integration, that you have your milestones that you can gain benefit early on. Because a lot of integration projects can last anywhere from 3 months, 6 months, but all the way to up to 5 years I've seen. And you want to have each milestone to gain significant benefit. And what you'll find is that you'll be able to get the low-hanging fruit early and really get tremendous benefit from your early milestones. So having more of a modular implementation is really important for integration. And it has been one of the challenges that we've had, or our clients have had on doing some integration. So some of the approaches that we've seen throughout the industry is mostly probably focused on manual reentry. So when you're talking about integrating and you're exchanging information from one system to another system, it's usually manual. And what the issues with this is quite obvious in the case that it takes a significant amount of time to actually re-enter this information, if it is just data entry or if it's even recreating your model in a different application for a different purpose, is that takes a substantial amount of time and effort. But as well as we're practicing concurrent engineering, so there's often changes or modifications that happen to our model that we need to be propagated through our environment. And doing that manual reentry multiple times is going to even cost more as we're practicing this concurrent engineering. And with entering this information, because we have to recreate it, there's more possibilities for error. So errors can be introduced into your connecting systems. So we've seen a lot of standards come around, such as IGES and STEP, as well as a lot of people are starting to use DWGs for AutoCAD drawings. And the problem with these or for some integrations they work well because it has information that you require. But a lot of the integrations that we need at a higher level doesn't really have the context or all the relationships or information we require to do the integration that we need. So, for example, if you're integrating with your ERP system, extracting your bill of materials from a DWG doesn't give you all the information and all the relationships that you require to have in your ERP or MRP system. So one thing that we resort to when we really want to leverage the connecting of two systems or multiple systems is custom development. And we've been part of quite a few, but we've actually been seeing the aftermath of a lot of the custom development. And what ends up happening is the requirements and the expectations that the custom development were set out to accomplish, you really don't get all the benefits that you anticipated at the beginning. And there's a lot of reasons for this, and it's a lot of the challenges that I mentioned before in the case that the expertise of the person integrating didn't know the systems very well. They created a very fragile system so that if anything changes on either systems, the integration breaks, and then therefore your maintenance cost is quite substantial. So there's a lot of reasons why the custom solution can actually be successful, but also can actually cause some issues. And largely it's because of the maintenance. So from that, I'm going to start talking about the SSI Enterprise Platform. And as if you guys have already realized that it's really focused on integration. So SSI has been having our flagship product, ShipConstructor, has supported the open architecture since the conception of it. And because of this open architecture, we've really been part of a lot of integrations with our clients, from integrating from ERP systems, MRP, PLM, PDM, but also to the shop floor, CNC machines for your profile cutting machines, and so forth. So we've been part of a lot of different integration projects, and we've got a lot of expertise on what were the common challenges. And we really set out to solve some of the challenges that we found that our clients were always encountering on virtually any integration. It doesn't matter what type of integration. They all had the fundamental same issues of collecting the right information at the right time. So this is just an example that you have your marine information model, which is ShipConstructor, comprising of the SQL database and the Autodesk platform. But virtually information has to be disseminated or distributed throughout the whole environment. So there's just a few here that I've listed, such as your resource management, your owner-operators, reviews for design and production reviews. You have analysis and simulation, document management, planning. There's a bunch of departments and stakeholders that require information from the marine information model, and they all have to access it in different ways because they need different types of information. So what the enterprise platform is really focused on is being the central location where all integration is going to be focused on. So it doesn't matter what product, what stakeholder, how you plan on doing your integration. It is the focal point of the solution that we want to use for integration using the marine information model. So to give you a little bit more of a structure view, the enterprise platform really is a layer on top of the marine information model, which again you can use all your systems, and this even goes down to your legacy systems and even just Excel. There's a lot of your integrations and systems that can import Excel. So using that as a interoperability or interfacing format can be used through the enterprise platform. One question I get quite often is with having the SSI Enterprise Platform and being the main connection point for integration, people always wonder if we're going to remove our current access points, being SQL, ShipConstructor API, and all the other various methods that we have. And the whole thing is we're not. We're actually expanding it. And the enterprise platform is really just a layer that is solely focused on consuming and exchanging information with applications. So it's really abstracting all the complexities that you require to do your integration, and really leverages our current methods. So when you look at your integrations that you have now, you have to get information in different representations, and I'll be talking about representations quite a bit. But when you're looking at accessing information, sometimes you need information of just in a bill of material format, so just in an Excel type format. But then you might need a representation such as a PDF or a PNG or a CNC. So these representations are not really in the marine information model. We don't store a PDF of a drawing. So you have to create these representations that are required as an input for your system that you're integrating with. And the enterprise platform is really what is going to be focused on solving that. It can collect all the information from the marine information model and use that as a source to generate new representations of drawings or parts. So when we're developing enterprise platform, we had a couple focus areas. First, we want it to be highly configurable. When we're working with a lot of our clients and just hearing some of their stories about their integration challenges that they had, we noticed that it was very service-oriented, that every time they wanted to alter or change their integration, they had to pay a consultant or get someone internal to do extra development to support that extra feature set that they want. And to support the idea that we know businesses are going to change, we wanted to make it so that the user would be able to configure the system on what they actually need at the time, and then if they need more information or different representations, that the user would be able to change it on their own without asking for assistance from SSI or other consultants. We want to concentrate on workflow. As I mentioned, workflow is probably one of the key areas where I think the majority of integrations fail, or you don't achieve the goals that you ideally wanted. So we really want to put workflow as our first-class citizen. The key to that is really that we want to really reduce the disturbance of any stakeholder. So it doesn't matter which end user, the consumer or the producer. So we really want to make sure that the end users are focused on what they are supposed to be doing and what is their job, and not really worry about how the information gets to their system, what happens when they pass their information, and what systems I have to integrate. They should be just focused on the generating and consuming information, and not really worry about how everything's going to be passed and distributed through the environment. And through that, we really focus on information and not technology. And this is important in the case that when you look at integration and when you're actually connecting to the technology that stores that information, it really doesn't make your solution a resilience to technology change. And we know that technology is changing at an exponential rate, and by tying integration to the technology really makes it more vulnerable to issues and upgrading down the road. So by making the platform really focus on the information, which doesn't change as much as the technology, and is really the currency of your marine environment, really allows us to make a more sustainable and scalable solution. Essentially, managing your integration from one location is very important, and we want to make sure that we support that. When you're integrating all of these systems and applications throughout your ecosystem, there is, these servers are located in different buildings or different, you might not even know where they're located. They might be in a different geolocation. So we want to actually have one area that you would have to manage your integration without having to connect to all these servers or these clients, and make sure that a person has access to it. So having it centrally managed allows a little bit more manageability on your integration. We want it to be product focused, and this is quite different from most integrations that you've probably been part of. And the whole thing is, what we want to do with this product being more product focused is the integration is more of a product that ends up getting purchased, and then it is maintained from the vendor, being SSI. So this really reduces the risk and even the cost to our clients about getting integrations or connecting their applications and having it maintained. So really, it's a little bit better total cost of ownership, and you can actually anticipate the cost. Having your information to be in sync and the integrity be solid was very important, because we're integrating with multiple systems that access information from the same source. And again, we just want to make sure that we embrace changes. The applications, the systems that you're integrating with today are going to be different than a year or 2 years from now. And we want to make sure that the platform was able to adapt with your business and your goals and objectives. So when solving any integration, we always go to the 5 W's. This is the key area that we have to solve when we're trying to solve an integration problem. So that's the why, when, what, where, and who. So why do I need the information? When do I need to pass this information? What information or data or formats do I need? Where do I have to put it? And who's the final recipient of my data that I'm transmitting? So from that, we broke it down to 3 main components. So the client, which really solves the why and when and some part of the what, is that we have to determine why and when do clients actually have to push information, or when does information need to be pushed through to the other systems. And it's really when the user is completing a task. So this can be a task such as building a unit, a block, it could be an ECO, or just a system. So they have this task that they're set out to accomplish, and when they're done this task, that's when they want to pass this information through all the systems that are connected into your environment. So also with that is that the what of what they're passing is really the changes that they've done, because with your project there's many parts and many assemblies and spools that they don't really have to pass all of the information of the project. You really just want them to pass the delta or the changes that they've done. So the parts, the drawings that they've created, updated, or modified down the system. Then the information hub takes that context of information that the client has passed. So not the artifacts, not the drawings, not the parts, but the context of the changes, and then really starts generating the different representations of information that you want or you require in your integration. So these are, again, the representations such as, if I get a particular part, I might need to get a bill of material properties for that part, or I might have to generate a PNG or a DWF file from that particular part. So the information hub is really what generates all the different representations. So it's really the what is what's going to be integrated into your system, and it's the only place where information is going through. So everything's going to be funneled through the information hub. Then from that is that you have your connector, and your connector is really what's going to take that representation of information that came from the information hub and pass it to all the connecting enterprise systems that are part of the enterprise platform. So the connector is the last piece of taking that information which was generated, the representation, mapping and translating it and integrating it into the final system. So I'm just going to get into a little bit more detail. So this was relatively high level. And this is the structure or the architecture of the enterprise platform. So the red components are the clients, then the information hub is the blue, obviously, and then we have the orange being the connectors, which might have a connector-adapter relationship. So I'm going to slowly go into each one a little bit more in depth to give you guys a better understanding of the enterprise platform. So the clients, we again focus on workflow being our first-class citizen, and to do this, that means that we had to really integrate the client into ShipConstructor. And to determine what the client has actually changed, so when we are trying to figure out the why and when to pass information, we created this concept of a ShipConstructor task. So what a ShipConstructor task is that it is a task that a user associates themselves to, and that any action that they do on the ShipConstructor project, that change is associated to that task. So if they create a part, if they delete a part, or modify a part, if they create drawings, update drawings, change stock attributes, all those changes are associated with that task. And what that allows us to do is that when that client has completed that task, being again building a unit or a block or doing an ECO, is that when they complete it, ShipConstructor can use all the changes that were associated with that task that that person changed and create a change set of what they've actually modified. So all the context of that change that they've done and pass it downstream to be processed through the other stages of the enterprise platform. So this means that the end user can just use ShipConstructor virtually as they do it today. The only real change is that they would have to associate themselves to a task, and then all the context of the changes they've done will get passed automatically. And they would not have to worry about if they're integrating with System A or System B or to do any other type of recipe type of workflows. So another workflow that we actually have is that you have the stakeholders that are going to be using ShipConstructor, but you're also going to have stakeholders and users that you want to be participating in this enterprise platform or asking or consuming or producing information, and they don't have ShipConstructor, or you don't want them to have ShipConstructor. So we have a way that a user can access what we're calling the publisher, where it will be able to initiate what information you want to consume or what information you want to produce. So this user that's outside could be on your production floor to get their deliverable packages. It can be your weight engineer to get information for integrating with the weight system that you're using. It can be your production review or planning team that wants to get planning and purchasing information. So it can be pretty much any user that needs to access information from the marine information model that does not require to have ShipConstructor. And then to support our open architecture, we have a gateway that allows third-party services through REST and JSON to access and to query information from the marine information model via the enterprise platform. So the benefits are that it's integrated into the system. You don't disrupt any of the stakeholders from any of the clients that are actually participating in the enterprise platform. Virtually no trainings required because it's relatively intuitive on the publisher as well as on the client. It's simply just selecting yourself a task. And we support automation and several workflows that make sense to your organization. The information hub is, as I was mentioning, this is really the workhorse of the system, and this receives, again, the context from the client. So it doesn't receive the drawings or the parts, it just receives that they've changed these parts in these drawings. And the reason being is because Information Hub is where all the configuration and option happens on what information needs to be generated and to be later consumed by other products. So this is 100% configured by the user, and it generates virtually any representation of that information that you want. So again, when you're passing in an assembly drawing, you can specify that I need a PDF format because I'm generating a work package, or I need a PNG because that's going to be integrated into my PDM system, as well as I need a bill of materials of that assembly and all the parts that contain that assembly for my integration with my ERP system. So it can actually generate virtually any information that any integration requires. When you look at the Information Hub, again, was mentioning, it does acquire information from SQL and our APIs, as well as generating of new information through ShipConstructor and AutoCAD. When it generates all the information, when it generates all the information, so this is the Information Hub, we're using a hub and spoke architecture. And what that means is that once it generates the package of virtually all the information that needs to be consumed by the connecting systems, is that it passes that same package to all the connectors that are connected to the Information Hub. So the benefit or the reason for that is that any connector that's connected to the system will have access to the exact same information. And even though the information that each connector might be pulling or any integration requires might use a different representation. So again, if we use the drawing and the assembly drawing, your ERP system might consume the bill of materials from that package, but your PLM system or your work package would generate or consume the PDF format. So they're different representations, but they're generated from the same source at the exact same time. So that means that all these connecting systems would actually have data that's in sync and their integrity would be high because they're pulling information from the exact same package. With the structure, we also have more of a plug-and-play model, so you can continue adding more connectors. So in your information hub, if you have one connector, that package only goes to one connector. If you have multiple connectors, that package just gets distributed across all the connectors. So you can really scale your system by adding more connectors or removing connectors without disrupting the rest of your integration environment. So the benefits, pretty much all the different types of information you want is available for any integration. You can manage and control what information gets generated from the information hub, and it's virtually one platform for all the integrations that you require. The last piece that we have is the connectors. So the connectors are the ones that are going to be pulling information from the information hub, the package that is generated. So the connector is really going to just simply do a translation and map. So because virtually all the hard work is done by determining why do I need this information, when do I pass it, generating all these types of information that I require, the connector really just has to consume the information it requires from that package and does a final translation into the system that's integrating. And because it's each enterprise system that you're integrating with has different architecture and technology, you in essence need one connector per enterprise system that you're integrating with. So this is where each of these connectors are going to be product focused, meaning that it's going to be a product that's going to be being able to be used and inserted into your environment. And then depending on the system you have, you would just have different products. And that product is built and maintained by SSI and our partners. So the benefits, reduced overall risk and cost, mainly because it is more of a product and the maintenance is coming on to SSI as your vendor. The resilience to technology, mainly in the case where if technology of the enterprise system as well as ShipConstructor changes, there's not really any change to the integration. Everything will continue working. So for sake of argument, if SSI decides to change our SQL database to a Oracle database, it would not affect this integration because our integrations focus on the information and the way that it's pulling information. It's non-disruptive in the case that you can keep on adding more connectors without worrying about other integration that you have in your production environment. So if you are trying to support a more modular implementation, you might just implement one specific connector, get that working properly, and then continue adding more and more connectors and really start building your ecosystem of integration projects. And the real key benefit of the connectors is it really adapts to any of the changes in your organization. So again, supporting your modular implementation, but also scaling and scalability, that if you're changing systems and you're adding a lot more projects or integrations, it can actually scale with you. As well, it's relatively flexible. You can exchange and surgically remove these connectors relatively easily. So this is, again, the architecture, and I just want to leave this on this slide and kind of open it up for any questions that I might have. So if you guys have any questions, you can ask it in the chat. We have Norman one of our product managers viewing the chat, or you can, I believe, unmute yourself. Norma, is there any questions? Okay. So I'll go on here. So this kind of leaves us to where we're at now. So that's our enterprise platform. And one of the developments that we kind of are working on is the publisher, which is came from a lot of the work that we did with the enterprise platform and what I'll be showing right now. So before I get into too much of what the publisher is, I just want to quickly go over again just more the workflow of how the enterprise platform worked and kind of show you how that transitioned into what the product or the publisher that we have today. So on the client side, we have, again, just the users and the clients, which will be publishing or specifying the context of data that they want to get generated or they want some actions to be performed on. That's then displayed on the publisher where there can be extra modifications. That information gets passed through the information hub, gets all the representations generated. The package gets created, and then that information gets orchestrated to all the participating connectors and eventually to the enterprise systems. So how the workflow relates to the functional design is similar to this. So the client, we have the modification engine, the graphical user interface, tasks, and the information hub. We have exactly configuration, generation of information, and orchestration. And the connectors, we have more of the mapping and translating. So the publisher is only several of these components for the full enterprise platform. So this is just so you can kind of relate to what the publisher is versus what the enterprise platform is. So the enterprise or the publisher does not have the connectors or any of the mapping and really the final integration with the systems that we're kind of talking about. As well as it doesn't have the orchestration, mainly because it doesn't have the connectors, and we have not implemented the modification engine. We're still working on that. So the publisher still gives you a lot of value, and majority of the value starts coming in the generation of information. So there's all this representations of data that we have to create, which I have been mentioning, and we haven't implemented all the ones that we've wanted, but we've implemented the ones that have significant high value, and with the clients that we've been working on, the ones that have been requested. So the publisher is one of the milestones that we had with the enterprise platform. So as integration projects are development, we do try to get milestones that have products at the end that are of high value. To be honest, we had more value out of this publisher than we anticipated. We weren't even planning on releasing this product. However, when we started demonstrating this to some of our clients, the common question that I got was, when can I have it? So after a bunch of discussions, we decided that we can actually create a product to be released to allow people to get benefit earlier on. So it is a separate executable, and the reason why it's a separate executable is because to support the multiple workflows where they might be a ShipConstructor user, they may not be a ShipConstructor user. So a non-ShipConstructor user can fully use this version of the publisher. However, this version of the publisher still requires to have ShipConstructor installed because it's more of an individual publisher that we're creating for this release. It does contain the majority of the heavy lifting, as I was mentioning. It has a lot of the configuration. One issue that we have, or not issue, one area that we're still working on is creating a better user experience on configuring and setting our options. So what you'll see here today as well as with the product is the configuration is really focused on XML. So you have to understand XML and be able to do your modifications there. But one thing that we still want to build is more of a graphical user interface over top of that, so make the setting it up quite a bit easier. With this, we also have persistence with our configuration as well as our selection criteria, so that if you are testing this, or usually when you set everything up into your company and you want to repeat several actions, that you're able to use those save criteria, so you don't always have to do multiple selections every time you want to use it. So it makes it a little bit more efficient as well as for automation. So this is just some of the UI that you'll see shortly. You have the main window here. The code name was SC Automator, so where you see SC Automator, that was just the code name for the publisher. Then you have a bunch of your wizards to how you actually select your parts, or what are your source items that you want to select, as well as various ways of filtering. And this is just a normal assembly structure, so we do pull information from ShipConstructor if you want to select that type of information. So if you want to select assemblies, we do show that information, which resembles exactly what you see in SSI or in ShipConstructor. And it's saying that I have low audio quality. Are you guys noticing any issues? Okay. So moving on to the workflow. So this is the workflow of the publisher right now. So from the user, they end up having the graphical user interface. From here, they're able to select the criteria, and this is where the criteria usually will come from tasks. When I was talking about the client perspective, where any changes they make in ShipConstructor, it's associated with the task, and then that gets pushed down the system. Since majority of you guys won't be using tasks, you'll have to select those sources specifically, or in the publisher. And the sources you can pick, or the selection criteria, is based off drawings, parts, assembly spools, and various other different sources. So this is the sources that would normally come with tasks, but will allow you to manually select them. And then you have your configuration of how you want to generate that information. Then after you've selected your criteria and what you want to do on that criteria, what actions you want to perform on the items, what the enterprise or the publisher will do is it will organize the requests. And the reason why we need to organize the requests is because some of the commands or actions you want to be called on the items have to be either initiated of an AutoCAD instance or a ShipConstructor instance, or even just you might have to go straight to the database to gather information. So we organize the type of requests you have and to understand how we can better utilize the resources on the machine. So from that, we kind of initiate the generation and the correlation of all the information, and start initiating several different AutoCADs and ShipConstructors and accessing the ShipConstructor marine information model. So supporting our focus on configurability, the number of instances of AutoCAD that I want to execute is, again, user configurable. So I can actually, in my configuration, specify how many ShipConstructors and AutoCADs I want to run to make this run a lot faster. So depending on your machine, you can run up to 10 or even 15 different AutoCADs and ShipConstructor to generate these representations that you require for your integration. So this is, again, the PDFs, the CNC files, and so forth. As it's running, it's continuing reporting information, so you can actually see a live report of the information that's getting generated, or if there's any errors or warnings, as well as it's obviously just generating your output. So this is the last slide before I start the demo. So some of the output that we have that we're generating is PNGs and JPEGs are just images files. We have DWIF files, we have DXFs, PDF files, step and IGES and status. So the first few are just mainly pure outputs that you can generate from AutoCAD, but generating it through a more automated and a much easier way of doing it, user-friendly way. Then we have some of the output, for example, if you want to generate a pure native AutoCAD drawing from ShipConstructor. You can actually create or use the system to actually create a pure native drawing. Then we also support a undetailed DWG, and this is really was focused on our FEA analysis, FEA integration. However, with some of the feedback we got from some of our clients, we, or I guess we're putting our efforts somewhere else from the feedback that we got from our clients. So it's still available. But this is, removing the corner treatments and end cuts as well as the flanging and creating a pure AutoCAD DWG or native DWG. Some integrations require a specific drawing per part, so we're able to create a drawing per each part. We also support non-ShipConstructor drawings for any of these integrations. So there's no requirement for this to work only on ShipConstructor or only on ShipConstructor drawings. Obviously, the ones that require ShipConstructor drawings are the ones that make sense to be ShipConstructor. However, we do create quite a few that are not. And these bill of materials are extracting AutoCAD tables and generating XML files are some of the commands. So what was requested by some of our clients was that they want to be able to open up a drawing from created from a different application, either from a third-party contractor that they are contracting to, or if they're just using a different application. But they want to extract the bill of materials via the BOM into an XML. So you can actually have these ways on accessing table information from non-ShipConstructor drawings. If you are using ShipConstructor for the drawings, usually what people end up going with is using the bill of materials. And what this allows you to do is that you can select the sources, and then you can select the attributes and properties that you require for the information that you want to generate. So any part or any assembly or spool, you can specify what information you want of those parts, and it would create an Excel file. And the benefit of that is that, say for example, your business and your organization's goals and objectives change, that you have to add one more UDA, for example, in ShipConstructor to record a specific attribute. That you can change your bill of materials, again, 100% user configured, that you can then therefore get the output of that UDA for that particular part on the output that is actually generated. We can generate Navisworks as well as Navisworks 4D simulation, and this is part of the Advantage Pack. There's definitely some limitations, and we're working on developing that, but you still can generate those files if that's one of the areas that you've been using. We've been working with a couple clients on trying to do profile cutting data exchange, so we're working with even some vendors of profile cutting machines and trying to get a format that can be used to be integrated into their system. So it's not fully detailed and completed yet, so that's actually something we're actively working on, but you can kind of see what is being generated. As well as with the new release of ShipConstructor 2014, we generate PCFs via the pipe link. So I'll start the demo here. If there's any questions, feel free to ask some questions. Okay, so this is the
is the NWC supposed to be NWD?
No.
On the last slide, okay.
No, it's NWC.
Clarifying.
Yeah. So this is I just started the publisher, so it's just an executable that I have a shortcut here. So it asks me to register to a ShipConstructor project, and this is my main UI that I have with my publisher. So the first thing that you want to do is that you want to change your output directory. So because this is really focused on generating the representations of information you want to make sure that the output directory is where all your output's going. So I've actually listed this into a specific directory in my ShipConstructor project called Published Files. And these folders, which you'll end up seeing, is something that gets automatically generated by the publisher because of my configurations that I use. So after I do that, usually you would want to load the items or the context of the changes that you want to do something with. So the drawings, the parts, the assemblies that I actually want something to happen to, or my actions to be performed on. And this is where you usually have your tasks, which would automatically get all the changes that you've done in ShipConstructor and then populate those items in here. But since I suspect the majority of you will not be using tasks, I'll just kind of do more the manual way. So the manual way is we have this load manager, and the very first question it asks us is what do we want to load? So what is the source item that we wanted to use to generate information? So you can use assemblies, drawings, parts, spools, and systems. So for this example, I'm going to just select drawings. I'll go back and select some parts as well. And then we can start now filtering what of the drawings that I've selected. Well, how do I want to filter it? Which drawings do I actually want to perform an action on? And you can select a specific one, or you can specify an SQL, so you can actually put virtually any information or have any criteria that you need to select the drawings. So you can select all the drawings that have been modified in the last 3 days by Joe. And you can enter that information in, save that criteria, and then every time that you're actually running this, it always generates or uses the drawings that Joe has changed in the last 3 days as your source. So I'm just going to select specific, and I'm just going to go a little quickly here because I'm starting to run out of time. So as you can see, this is just a familiar user interface that you would see in ShipConstructor from Navigator or Project Explorer, and you can just specifically specify which drawings you want to actually to use as your source. As well as we have many ways to filter information from the filter row up here to the units, as well as the type of drawings. So there's many ways that you can filter down the drawings that you actually want to select. But I'm just going to select the 3 first frame drawings. And I'm just going to show you other ones as well. So parts, you can select parts by different filters. So I can select parts via assemblies, drawings, and so forth. I'm going to go by assemblies. So you can see that it's categorizing my source items by the type, my drawings and my parts. Gives me the source item and as well as the item type of what they actually are, so I can do actions to them. Another thing that I want to show to you is that you can load external drawings, so drawings that are not ShipConstructor that you want to do actions to, and this is common if you have subcontractors or if you're using a different application. And so I have a project here that doesn't, so we select that folder, and these are all drawings that come from an external source. And just so these are all my source items. Say these are what I want to use, and these are the ones I want to perform an action on. So the question though I have to do now is, what action do I want to perform on these drawings and these parts? So this is where we have an XML that defines all the actions that we can actually do on a part or an assembly or a spool. And this is the XML that I was talking to you before. So what you can end up seeing is that when I select these items and I select an operation, that these are the operations that I'm able to do on these items. And this is 100% generated from this information that I have in my Excel file or XML file. So as you can see, I have Denis open save, now it works 4D, PNG for all layouts, and it's exactly what I have here. So the benefit from here is that each user that's using this publisher can have their own configuration. So if you have particular departments such as your weight engineer, they can only have the commands that's relevant for them. If you have your production floor or even just an engineer, your simulation, your review team, they can have their own configuration to generate the output that they actually need. So what I actually will be using for this demo is that I created this I guess command that ends up calling a specific command for the type of drawing that I have. So to kind of give you an idea of what it looks like is that for this command that I'm calling, for each of the drawing types, I specify exactly the output that I want to generate. So if it's an approval drawing, it's a build strategy, composite drawing, and so forth. So I'm specifying exactly what I want for that type of drawing. So I'm not restricted to have the same output for all the inputs. I can actually have logic in there to determine what input I'm getting to be more specific and generate the output that I want from it. So for example, for my planar group drawings, I don't need to generate a PDF file. I just have to create some images and then export. But my assembly drawings and my arrangement drawings, I want to also create a PDF file. So I can specify that for arrangement drawings, I want a PDF file as well as other output, and my planar group drawings, I specify something different. Now for parts, I can select an operation, and again, using the same configuration, it has the options that I want to select, and these are the ones that I'm just going to select for this demo, even though I'm not going to generate output for some of these curved plates. But we have output that you can generate a specific drawing per part. Also, you can generate a profile DXF and the part bill of materials for each part that's consumed in or selected in the parts. So after you select all your criteria and what you want to happen, you end up selecting Run. So as you see right now, this is running AutoCAD and ShipConstructor in the background without me really doing anything. And it's going to only run 2 AutoCADs or ShipConstructors, and the reason is because I'm just running this on a laptop right now, and I just want to keep it my laptop a little bit more responsive for this demo, as well as I'm going to be showing you some other stuff while this is working in the background. But what you can kind of see is that it's connecting to my project. It's going to be opening the drawings that it requires to open and generating the output that I specified that I want to generate. So they're starting to open some of the drawings. You can kind of see I have 2 drawings opening, and it's generating PDFs and NWC files and other formats. So what I can kind of start seeing is that my output that I've specified, this is the folder where I wanted my outputs to be. And through the configuration, I've actually specified that I want to name the folder by the date. So this is the date that it just created, right now, or just when it started. So these folders, again, are created by the publisher by specifying in my configuration that nothing's hard-coded, everything's user configurable, and all my output is starting to go there. So it's exporting drawings, it's creating Navisworks files, and PNGs of the files that it's opening. So to give you a little bit more context of the output that it can generate, just so that we don't have to wait around, I generated a few days ago. So this is pretty much generating a bunch of output from a project that I have, which is more the training and demo project, which has about, I think, 8,000 parts. So some of the outputs that I want to show you just for the demo. So this is an assembly drawing. So again, what I end up doing is my output is for each type of drawing, I specified the folder that I want all its output to be to go into, just to categorize it. But again, this can actually be structured whichever way you want. So when you do your work packages, for example, you can structure it with whatever makes sense. So in my assembly drawing, these are the outputs that I generated. I generated a bill of materials, which gives me an XML file of the columns, as well as with the value of the table that's in there. I also generated DWIFs, export drawings, PDFs, images. I'm going to show images a little bit more because it's easy to visualize. But these are the images that I created automatically using the printing settings that I had determined in my configuration. Also, the bill of materials, which is going to be a common part of the information that you're going to want to generate, is these are the parts such as your that are more integrated into Excel. So what it generated is for all the parts in my drawing, I selected absolutely every single column or possibility of attribute that I can possibly select for just more for reference, just so you can see what is actually available. But all this is 100% configurable in the case of I can specifically specify what columns I actually want or what attributes I want. But you can kind of see that through this, each part has virtually all the information exposed in this Excel. So it's rank, it's revision, quantity, purchase, the piece type of the type of part that it actually is. It has its assembly, and also the key thing also, it even has the assembly or the assembly GUID, the spool GUID, and the part GUID. And these are really important if you're doing integration with other systems, because it gives you some identification of what that part is, because that part GUID, for example, doesn't change, so you know if it's been modified, created, or deleted. So virtually, again, I just want to show that any information that you want on the part is available, and you can specify what you want to see. Some other cool output is the part DWGs, and it's just a representation of a drawing for each part. And again, I named it. The naming convention I used is I just used the GUID of the part, and I guess export it because it's creating a pure AutoCAD drawing. So if I actually look at one of these drawings, I'm not sure if it's completed. Actually, that might mess things up or not. So it's my integration is still running in the background. As you can see here, it failed on some items. It's giving me a summary of all the issues that's happening, giving me progress, and giving me a log. And when it's completed, I'll have a little bit more of a summary. But again, this is my the part that I opened up for you guys, and it's just a pure 3D solid. And that was again just generated from the system. So to kind of give you a cool representation of all the parts, so what I did is I created a DWG per part, and then I created an image from that part. And these are all the parts that are in my project, individual DWG. So it can show you what is actually available. We have our profile cutting machine, which these are just DXFs that are required for integration. It has special information such as X data and layering to support integration with profile machines. And just because of time, one last thing I'm going to show is just the generation of PCF files, which is one of our new formats. A lot of integration and a lot of applications as well as integration require PCFs. It's more the de facto standard. So you can generate PCFs automatically, and from that I created DWIGs and also created images just so I can visually see what the PCF file has. So again, all this stuff was automatically generated in the exact same manner that I was just showing you before, just select different inputs and different outputs. So sorry that it took a little bit longer than anticipated, but there'll be more information on the publisher later on. But if you guys have any questions right now, feel free to ask me some questions. Okay, if there's no questions, are you getting any questions there, Norman?
Oh, nope, no questions. It's all clear. Quiet crowd.
Perfect. It's lunchtime for many of them. Okay, thank you. I'm going to stop the recording, and this is recorded, so you'll be able to see it at a later time, or if a colleague of yours requires it. Thank you very much.